I'm Dr. Carl Schreck. In this video, I'm going to be talking about some of the large-scale climate factors that were associated with Hurricane Helene. Specifically, we'll be talking about how the Atlantic Ocean was record hot during 2024, and that likely fueled a lot of the wind and rain. Now, some of that was natural variability, but also some component of it was associated with human-induced climate change. In addition to the hot Atlantic, the Pacific was actually cooler than usual with a La Niña event there. And both of those, the warm Atlantic and the La Niña in the Pacific, both tend to encourage an active hurricane season. And so a lot of forecasters were expecting that to happen, and it started off really strong, but then it was actually really quiet up until Hurricane Helene. Even so, forecasters were able to predict that something was going to form in the Caribbean about 2 weeks before Helene did, although they had no idea what a devastating storm it was actually going to be. First, in order to understand the climate impacts on a hurricane, we need to talk about the hurricane heat engine, which is essentially the way we as scientists talk about how hurricanes get their fuel from the difference in temperature between the ocean and the upper atmosphere. As the winds in a hurricane spiral inwards towards the eye and the eye wall, they're collecting the heat and moisture out of the ocean. And then once they reach the eye wall, that kind of donut shape in the middle of the hurricane, the winds blow up to the upper atmosphere. Everything in the tropics is all about in, up, and out. So the wind spirals inward, goes up through the eye wall, and then transports that warm, moist air out far away from the storm at the upper atmosphere. Now, a big part of what determines how much fuel the hurricanes have to work with is what we call the Atlantic Multi-Decadal Oscillation, or AMO. And so this is essentially the average temperature of the entire North Atlantic Ocean. And here I'm showing a graph going back to the 1800s. And there are decades where it's been cooler than normal, decades where it's warmer than normal, and those tend to correlate with more or less active periods for hurricanes. So for example, in the 1930s, it was hotter than normal and we had more hurricanes than we typically would see. Then it was cooler than normal in the 60s and 70s and hurricanes were relatively quiet. Since 1995, it's been hot and we've had really high hurricane activity. Now, some of this is natural variations in the Atlantic overturning circulation, but some of it's also associated with human-induced climate change. As we burn more fossil fuels and emit more carbon dioxide into the atmosphere, the oceans are absorbing a lot of that extra heat. In addition, over the Atlantic, it's also been affected by the amount of aerosols or soot that we put out from our power plants. So after World War II, they built a lot of power plants along the East Coast, and those were putting a lot of smog and soot out over the Atlantic that was blocking some of the sunlight. When the Clean Air Act was passed in the 1970s, those power plants started to get cleaner and cleaner, allowing more sunlight into the Atlantic and allowing it to warm up. And so the warmth that we're seeing now is some combination of natural variations in the circulation, changes in how much soot and smog we're emitting, and also changes in how much carbon dioxide we've put into the atmosphere. Even aside from all of that, 2024 was record hot. So here on the left, I'm showing a time series of the oceanic heat content over the main development region, which is essentially from the east coast of Africa to the west coast of Central America, which is where most hurricanes tend to form and develop. The blue line is the typical annual cycle. It's generally cooler during early spring and gets hottest in late summer, early fall when the hurricane season peaks in September or October. All the gray lines are individual years for the last 10 years or so, and then the light red is 2023 and the dark red is 2024. You can see in early spring of 2023, things were still pretty much normal in the Atlantic, but then sometime around June, it just shot up way higher than anything that had been observed previously. And it basically stayed there all through the rest of 2023 and all through 2024. And it's only come back down in the last several months. So having this really hot Atlantic, we knew that was going to fuel potentially a really active hurricane season. In addition to that heat source from the ocean, the other main thing for a developing hurricane is what we call vertical wind shear, which is just a fancy word for the difference in wind speed from the surface to the upper atmosphere. If those winds are pretty much the same, then that heat engine can run more efficiently and you get a stronger hurricane. If the wind is really different at those levels, it can actually bend the storm over. You probably think about hurricanes as having a lot of wind themselves, but it turns out that the jet stream is actually even stronger than a hurricane. And so that's why the jet stream, when it interacts with a hurricane, can actually blow the storm over. And that's what I'm showing in this satellite image here, where those gray colors, that's the low-level swirl of clouds down at the ocean. And the brighter colors are all the deeper thunderstorms, and they're all getting blown off to the east by the jet stream. So that heat engine just can't run as efficiently as it would like to. Now, one of the biggest things that affects the vertical wind shear is El Nino and La Nina in the Pacific Ocean. During a typical year or a La Nina year, the winds tend to blow from South America westward towards Indonesia and Australia. And that pushes all that warm water off to the West Pacific, pulling up cold water from deep underneath the Eastern Pacific. As a result, the warmest water in the entire world is in the West Pacific. And that's also where you get some of the strongest rainfall and biggest thunderstorms. And as I mentioned earlier, everything in the tropics is about in, up, and out. So the winds are blowing in at the surface, they blow up through those big thunderstorms in the West Pacific, and then they blow out and feed the jet stream. So during a La Nina year, that's all happening way out west in the Western Pacific, and so our jet stream tends to be a little bit more weaker and wobblier and tends to be more favorable for hurricanes. Some years, the winds at the surface that blow all that water westward from South America to Indonesia, those winds weaken, and all that warm water sloshes back to the other side, and you end up with the hottest water and the biggest thunderstorms are actually in the Central Pacific, closer to Hawaii and further away from Indonesia. Now there's the outflow from those storms, it's closer to our jet stream, and it starts enhancing the subtropical jet along the southern coast of the US. And that causes a lot of extra vertical wind shear that tends to limit the amount of hurricane activity. Looking at the ocean map anomalies for 2024, we see again that really hot Atlantic, those bright reds, and then in the equatorial Pacific you see some blues indicating a weak La Nina event there. And both of these were forecast fairly well months in advance, and so forecasters are able to use that information to anticipate an active hurricane season. Lots of groups put out seasonal hurricane outlooks. NOAA's National Weather Service puts one out, Colorado State University, those are kind of the two big ones that tend to make headlines, but there are dozens of groups that put out these seasonal forecasts, generally based on the conditions in the Atlantic and the conditions in the Pacific, the AMO and El Nino or La Nina. And all of them were seeing we were going to have a really active hurricane season, expecting pretty much what we got of around 11 or 12 hurricanes. However, it was a very strange active hurricane season. So this is a time series of accumulated cyclone energy, ACE, which is just a fancy way of summing up how strong the hurricanes are, how many they are, and how long they're lasting. The black line, again, is the climatological typical year. You see it peaks around the middle of September. The gray lines are individual years for the last 70 years, and the red line is 2024. 2024 got off to a really hot start with Hurricane Beryl, the earliest Category 5 hurricane on record in the Atlantic. So all of us forecasters were seeing, okay, we have warm Atlantic, a La Nina in the Pacific, and we've already had this earliest Category 5 hurricane on record. This is going to be a very bad hurricane season. And then it was really quiet. It was actually one of the quietest on record from mid-August through mid-September, which is typically the peak of the hurricane season. Now, part of why it was so quiet is what we call the Madden-Julian oscillation, or the MJO. And this is similar to El Nino and La Nina, except where El Nino and La Nina happen every year or so, the MJO happens every week or two. And so what you see is sometimes these thunderstorms will form in the Indian Ocean and gradually move eastward across the maritime continent, Indonesia, and into the Western Pacific. And as it's moving around the world, the MJO is affecting the vertical wind shear just like El Nino and La Niña do, but it does it much faster. And we track the MJO on this really crazy looking diagram here on the left, where the further outside the circle it is, the stronger the MJO is. And where it falls around the circle, that tells you where those heaviest thunderstorms are. And so we knew that typically hurricanes are most favored during phases 8, 1, 2, and 3, when the MJO is over the Western Hemisphere, Africa, or the Indian Ocean, because those are places where it tends to weaken the vertical wind shear, just like La Niña does. So we were a little surprised by the lack of activity towards the end of August, when we were in those favorable phases. However, we knew that coming out of that, through the first half of September, we were in phases 4, 5, 6, and 7. Those tend to be less active periods for hurricanes because you have more vertical wind shear. However, we also know that the MJO really tends to go around this circle counterclockwise at a pretty regular clip. So we were able to see that towards the middle of September, we were expecting that a few weeks later, we would be back in those more active phases. And that's exactly what ended up happening. In particular, we were expecting the MJO to interact with what we call the Central American Gyre. This is a big low pressure system that sometimes forms near Central America and kind of spins counterclockwise around there. It's much larger and weaker than a tropical cyclone, but sometimes tropical storms and hurricanes can form along the periphery. Sometimes they form in the Caribbean, sometimes the Southern Gulf, sometimes the East Pacific. But we could see in our forecast that as the MJO was coming back around, it was going to enhance the equatorial westerlies on the southern edge of that Central American gyre and make it more favorable for something to form there. So in fact, back on September 10th of 2024, the Climate Prediction Center put out this outlook showing that in week 3, they were expecting an enhanced likelihood of tropical cyclone formation in the Caribbean Sea and the East Pacific. Now, you may have forgotten that just before Hurricane Helene was becoming active, there was also Hurricane John in the East Pacific. So that was associated also with that Central American gyre and the dark red in this forecast. But Hurricane Helene also formed within that gyre. Now, we had no idea that it was going to follow this track up into Western North Carolina. We had no idea it was going to get as strong as it was, but we had a pretty good idea that something was going to form 3 weeks later. And so after that really quiet period in the middle of the hurricane season, 2024 finished off with a bang, starting with Hurricane Helene. Apparently, there was an I, J, K, and L named storm. I didn't have internet during that time, so I don't really know much about those storms. But I was back online in time for Hurricane Milton, which caused a lot of damage in the Tampa Bay area. So even though 2024 ended up being an active season, it got there in just this really, really strange way. Now, zooming out and looking at how climate change might affect events like Hurricane Helene, there are some things we understand a lot better than others when it comes to climate change. It makes a lot of sense that if you have a warming planet, heat waves are going to get more common and more intense. It's also fairly well understood for us that as the air gets warmer, it can hold more water vapor, more moisture. And so that means when you have a heavy rainfall event today, it's going to be raining a bit harder than it would have 50 or 100 years ago. And we also know hurricanes are especially efficient at wringing that extra moisture out of the atmosphere. Another thing we understand pretty well is coastal flooding. Places like Miami, Charleston, and Wilmington are starting to have coastal flooding events on a sunny day if there's just a king tide. You can imagine if the ocean is already starting at a higher place, what's going to happen when you have a hurricane come through with storm surge. Now, there's other things our science shows are probably happening, but we're not as confident about. We think that wildfires are becoming more frequent and intense. We think there's more drought risk. And we think that the hurricanes we're getting today are at least a little bit stronger than they were before. We have a little bit lower confidence that as a result of that, we're going to have more of these Category 4 and 5 storms like Helene and Milton. but the science is not quite as well understood for those really intense storms. So in this video, we talked about some of the large-scale climate factors, how the Atlantic was record hot, and that likely played a role in Hurricane Helene's wind and rain. In addition to the Atlantic, the Pacific was in a La Niña state. It was cooler than normal, and that also tends to enhance hurricane conditions. And so we were really expecting 2024 to be a really active hurricane season, except it didn't quite play out that way. It started off strong, it ended strong, but the middle was really, really quiet. Even so, because of the MJO, the Madden-Julian oscillation, we were able to predict about 2 or 3 weeks ahead of time that something was going to form in the Caribbean. But of course, we had no idea that it would end up being Hurricane Helene and affecting our region the way it did.